Hello, this is Mr. Ensler, and we are going to go through the Chapter 10 review. I hope to go through everything slowly and in a way that will make sense to you, because if you're watching this, it probably means that you would like to review and learn these concepts. So, this chapter is all about circles, and as you can see in the first four examples, in each of these circles, we have a line or a segment that is just going right up to the circle and is just barely touching it. It's just grazing it. And what we call that line, say from B to A, we call that a tangent line or a tangent segment. It could be a line or a segment. And that's tangent. And one of the things that we learned in the very first lesson of 10.1 is that if you have a tangent line, a line that is tangent, then it will be perpendicular to the radius. It will form a right angle. So I know these triangles give you a right angle. It's already pointed out that there is one, but even if there wasn't one there, that's something that we should know. So the first four questions ask us to find the value of x, and all we really need to do is use the Pythagorean theorem. So on number 1, we can see that 100 is the hypotenuse, so make sure we set this up correctly. I'm going to do x squared plus 96 squared equals 100 squared. I mean, really, for a problem like this where you're given a right triangle, the fact that there's a circle here kind of doesn't matter because you already know there's a right triangle and you can use the Pythagorean theorem. Okay. Let's figure out what these are. 96 squared is 9,216. 100 squared is 10,000. And then we still have x squared. So we'll have to subtract 9216 from both sides. And we get 784. And so then we would take the square root of both sides to get x totally by itself. Now when you take the square root, you need a plus or minus sign. We might not use both of those, but technically there are two answers that would do that. There are two numbers that if you square them would equal 784. So I'm going to type in square root 784, and ooh, it comes out evenly, nice, to 28. So positive or negative 28, although now, getting down to business, we can see that x is representing a length, so it really can't be negative. So I guess if you didn't have the negative part, that's fine because in this case, it's only the positive answer that we want. So make sure you show some work as you do that. Let's do number 2. Okay, in number 2, we have the same kind of setup. We have a right triangle, and we want to figure out the hypotenuse, so go ahead and set this up. 108 squared plus 45 squared equals x squared. So you can see what 108 squared equals and what 45 squared equals. You just type that in your calculator, and then we add them up, and we'll take the square root. And in this case, it works out evenly again. That's convenient. To 117. There would be a plus and minus answer, but again, the negative answer is not going to become necessary because this is a distance, and a negative number cannot be a distance. Alright, now look at number 3. You might notice this looks a little different. Yeah, this one is going to be more complicated. We do have a right triangle still, so we're still going to set up the Pythagorean theorem. So one leg is x, so we can do x squared. And the other leg is 32, so we can do plus 32 squared equals. Now, the third side, the hypotenuse, is not just x and it's not just 16. It's both of those added together. So you have to write it like this, x plus 16 squared. And you have to use parentheses because you're not just squaring one of them, you're squaring both of them. So how do you actually square that? Well, to do this, what this really means is x plus 16 times x plus 16. Sometimes people forget that, and they just kind of square both of them, but that's not really what you're doing. You have to square the whole thing, which means writing it out twice. Now, from there, you can FOIL it, or you can use the box method. The box method, you might remember, is, since this is a binomial, a 2 times a 2, you would make a 2 by 2 box, and you would write x plus 16 and x plus 16, and you just multiply in each one. So here, x times x is x squared. Here, x times 16 is 16x. Here is also 16x, and then 16 times 16 is 256. And then notice that these two terms are like terms. So, what this side equals on the right is x squared plus 32x, that's what you get when you add 16x plus 16x, plus 256. See how it wouldn't quite work if you just squared x and squared 16, you'd get x squared, you get 256, you would not get this 32x. And as you'll see, that 32x actually is one of the most important parts. Now we still have to do the left side here. So we'll have x squared, and then got to type in 32 squared, and we get 1024. Alright, from here we want to try to get the x by itself. I would actually probably subtract x squared from each side, and something kind of nice happens when we do that. They both go away. This is no longer a squared problem. So that's kind of nice. I'm just going to rewrite here. Now we just have a single x. That made this a lot easier. I'm going to subtract the 256. So 1024 minus 256 is 768. And then we'll divide that by 32, and we get our answer of 24. And that would seem to make sense. If you put 24 back in up here, that would seem to be about right. Alright, number 4, the final one of these. Here's another one, and you can see again this hypotenuse is split up into 2. So we're going to have to use the same kind of method here on number 4. So I'm still going to start with x squared plus 56 squared equals, now we want this whole hypotenuse side squared. So that's x plus 32 parentheses squared. Which means that you're writing it out twice, x plus 32 times x plus 32. Now you can use the box method again on this, or if you want, you can just use regular old FOIL, F-O-I-L. F stands for firsts, so in this case the first would be x times x, and that just is x squared. The outsides, O, is x times 32, the numbers on the very outside, so that's going to be 32x. The inside numbers is also going to equal. They're also going to equal 32x, and the lasts, that's the last of each group, 32 times 32, so that's where we will square 32, and we get 1024. Okay, and you notice these two terms can be combined. Usually when we FOIL, we can combine some terms. So the right side of this equation is going to say x squared plus 64x plus 1024. On the right side, we still have x squared. What's 56 squared? It is 3,136. So this is very similar to the last one. We can take away x squared from both sides, and that's very convenient because they'll both go away, and now there's only a single x left in this problem. That makes it a lot easier to solve. So to get that x by itself, I'm going to subtract 1024 from each side, and that's going to equal 2,112. And then divide that by 64, and we get 33. And that would seem to be reasonable. It's not a bad idea to just check it for reasonableness. If this was 33, this whole thing would be 65, and this would be 33, and that would make sense. The hypotenuse would be the longest side. Okay, so that was all lesson 10.1. Now, these questions, 5 through 12, all deal with lesson 10.2, which is where we introduce you to the idea of an arc. When you have a circle, there are two types of measurements that we're going to look at in this example. There are these inside angles, and they all have a degree measurement, and going all the way around, all of these would add up to 360. But there's also a measurement going around the outside of the circle, and we call those arcs. For instance, from S to R going along this curve, we would call that arc SR, and we draw that little curve over it. And if we wanted to know the measure of arc SR, it's going to match the same measure as the central angle in the middle of the circle. So it's also going to equal 42 degrees. We learned some shortcuts with some theorems that relate to other situations, but not this situation. In this situation, we're just using the fact that if the central angle is 42, then the measure of the arc will be 42. We had a different situation, and I'll mention this in more detail later, but if we have a circle and we have what's called an inscribed angle, an angle that's formed on the circle itself. Notice I'm not in the center here. I'm on the angle itself. If we knew that that angle was, let's say, 35 degrees, that would mean that this arc right here would be double it, 70 degrees. But that's not going to happen with this example that we have here, because these are central angles. I'm going to go ahead and erase that example and get it out of the way here. Okay. The other thing that I would want to mention is that if it looks like there is a straight line running through the circle and it runs right through the center, then that line would be a diameter. For instance, this right here would be a diameter, and it's going to split this side of the circle into 180 degrees, because that's half 360, and this side also into 180. So use that to your advantage. All right, let's go through and tell what each one of these are. First up is PQ. Okay, PQ, so you can see, is right here. And since this angle is 42, this angle will also be 42, just because they are vertical angles. Remember what happens when you have an X shape formed. You know, if you just have two angles formed by an X, the vertical angles are congruent. So number 5 is 42 degrees. All right, number 6, ST. ST. So we want this measurement right here. And we don't know what that is. We don't know what the central angle is either. But remember what we talked about. If this whole thing is 180, I can figure this out by subtraction. I can do 180 minus 64 minus 42. And when you type that into your calculator, you get 74. That means that both this angle right here is 74, and this arc measure is also 74. So the measure of ST is 74 degrees. All right, number 7, the measure of RT. Where is RT? All right, here is RT. Well, since we know each of these measures, we can simply add them together. 42 plus 74. So we're basically adding together our previous two answers, and we get 116 degrees. I'm just going to circle my final answers here to set them apart. Now look at number 8. We have the measure of TPS. There are 3 letters, so you have to follow those in order. Maybe at first I'll start with T, and if I trace starting at T, if I go T, P, and then backwards to S, you would not want to do that. That doesn't make sense. Or if I went T all the way around P and then backwards to S, that wouldn't make sense either. So you want to figure out what the angle is without going backwards. And so here is the way that you would have to look at that measure, T, P around to S. Now you could add up all of those. There's probably a way you could do that. But what I would say is easier is this is basically the whole circle except for this arc right here, which is 74. So I would just do 360 minus 74. And if you type that in, you get 286 degrees. That would be the measure of TPS. All right, number 9, measure of QR, arc QR. QR is right here. I know that from Q to S is 180, and this is 42, so we can just subtract 180 minus 42. And 180 minus 42 is 138 degrees. Number 10, measure of RQS. Where's RQS? Let's see here. RQS. Oh, again, we're going almost the whole way around the circle. We're doing 360 degrees, except not this 42. So I'm going to do 360 minus 42, and that would equal 318 degrees. All right, measure of PS is next. Where is PS? Let's see here. Now, this question comes up every now and then. Is PS from here to here, like that? Or is it from here to here? Aren't those both PS? Well, yeah, they are both PS. So when you can't tell, when it's ambiguous like that, always go with the smaller one. We call this a major arc, the bigger one, and a minor arc, the smaller one. And every time you have an arc, there's actually two. There's a minor and a major. I haven't mentioned this yet in this video, but you would want to go with the minor arc. So PS would be 64 plus 74 added together. And 64 plus 74 is 138 degrees. All right, last one of these. Number 12, the measure of PTR. PTR. Well, to me, this looks like a straight line, right? This would be 180. So I'm just going to say 180 degrees. You could also, if you wanted, add up 64 plus 74 plus 42, and that should also equal 180. All right. On the next page, we're going to be using a lot of theorems. You remember that in this chapter 10 we learned and went over a lot of theorems. We did 3 or 4 per day. So we probably have 15 or 20 theorems, and you don't have to memorize them. You will be given the postulates, theorems, formulas packet to use on the test. But make sure you're familiar with them. Just because you don't have to memorize the theorems doesn't mean that you don't have to study. You do have to study. And that's part of what I'm going to help you with. So in this first example, we're using a theorem that talks about an inscribed angle. We talked about this earlier in the video if you were watching, and if not, let me just demonstrate here. If you have a circle with an angle that's right on the circle itself, it's not in the center, it's right on the circle, that angle, let's say this angle is 80 degrees. Let's say this is 80 degrees. Well, the arc that is formed because of that, so this arc right here, is going to be exactly twice. So this arc right here would be 160 degrees. It also works the other way around. If you have a circle and you have an inscribed angle, and I tell you that this arc has a measure of 50 degrees, well then you can have that, you can cut it in half and figure out that this angle here must be 25 degrees. Okay, I'm going to go on to number 13 now. So in this example, you can see we have our inscribed angle. It's forming an arc measure of 130. So if you do 130 divided by 2, that's going to equal 65 degrees. That means this measure right here of angle C is 65 degrees. Now, that was not the exact question that we're supposed to answer. We're supposed to come up with the measure of arc AC. Arc AC is right here. And so we're actually going to use a different theorem. There's a lot of theorems, and part of it's just knowing which one to use, but I want you to be familiar with all of them. We have a theorem that says if two chords in a circle are congruent, that means their arcs will also be congruent. So I don't know what AC is. I'll call it X, but that means that CB is also X. So what I would do is I would do 360 minus 130, and that equals 230 degrees. And then we know that these two arcs together have to equal 230, so just split them in half evenly since we know that they are equal. And you come up with 115 degrees. So the measure of arc AC would be 115. In fact, both of these are 115. In number 14, we have 4 congruent chords. Look at this chord, and this chord, and this chord, and this chord are all congruent. So what that means is that these arc measures are also all congruent. And since there are only 4 of them, these 4 make up the whole thing, I would simply do 360 divided by 4 equals 90. That means that each one of these arcs has a measure of 90 degrees. So LM is 90 degrees. There are a bunch of different ways you could do that. That's just the way that I would approach number 14. I think that's the easiest way. All right, number 15. There's a lot of ways to look at this also. I just happen to notice when I look at the 2 arc measures that are given, 38 and 142, if you added those together, 38 plus 142, that would equal exactly 180 degrees. That means from M to K would split the circle into 180 on this side, and that would mean you'd have to have 180 on this side also. So if we need to find KLM, we know that that is 180 degrees. There are other ways you could come up with that answer. That's just the way that I would do it. Okay. With number 16 here, a lot of people would be tempted to say, oh, since these 2 are congruent, maybe this third one is also congruent. But that's kind of more a wish or a hope. There's really no information that says if 2 are congruent, then this one is also congruent. We don't really have any good reason for saying that. But, much like number 14, if 2 chords are congruent, that means their arcs are also going to be congruent. And so that's what's happening here. Because AC is congruent to CB, their arcs are also going to be congruent. So I'm going to do this the same way that we did number 14. I'm going to do 360 minus 116, and that equals 244. So that means that these 2 arcs together equal 244. Well, I know these 2 arcs have the same measure, so now do 244 divided by 2, and you get 122. So that means each of them are 122 degrees. So note, they're not all 116. In fact, only this one is 116. Okay, we have some more theorems to use with the next set. In number 17, we have a theorem that says, and if you look at the theorem in your packet, it looks just like this setup. It says if you have 2 tangent segments that are hitting a circle and they're both starting at the exact same point outside the circle, those 2 segments will be congruent. So all you have to do is set them equal to each other and solve. I would subtract the x from each side, and then I would add 4. Really, this stuff is review. You should already know how to do this, but I'll go through it anyway. And then divide by 4, and we get our answer of 3. Make sure that it makes some sense. If I put 3 in, I don't see any problems that would cause. You know, some of the problems that we want to be looking out for are, does it cause any of the side lengths to be 0 or negative? Because those wouldn't really be side lengths then. Those wouldn't be segments. All right, number 18, we had 2 theorems that dealt with this situation in number 18. Actually, the one theorem that comes to my mind first says that if you have a circle, and if one chord perpendicularly bisects another chord, see how this one is perpendicular and it's bisecting, that would mean that that chord that's doing the bisecting is a diameter. It is going through the center. Now in this case, we already know this is a diameter because we can see it's a chord going all the way across the circle and it goes through the center. So this is a follow-up theorem to that, which says if you have a diameter perpendicular to another chord, then that chord must be bisected, and you can just set them equal. 4x plus 5 equals 6x minus 9. In this lesson, I believe this was 10.3, we just did a lot of setting equal. and solving. The only new step, the only thing that we learned is how to set it up. What I'm doing now, solving, that is review. And then I would add 9. And so in this case, x equals 7, and I don't think that will cause any problems. I mean, think about this theorem. That means if you draw a circle, that's not a very good one, but oh well, and if you draw a diameter, if you were to draw another chord that's perpendicular, let's say right here, that looks like about 90 degrees, that would mean that it is bisecting that chord. There's just no other way that this is possible. Alright, in number 19, what we have is a quadrilateral, kind of looks like a trapezoid, but I don't know for sure, but it's a 4-sided figure, and it's perfectly inscribed in the circle. That means that each of the vertices is hitting the circle exactly on the circle itself. It's not really intersecting it, it's hitting it right on. That means it's inscribed. And we have a theorem that simply says if a quadrilateral is inscribed in a circle, the opposite angles, for instance 63 and 3x, they're not going to be congruent, but 63 and 3x will add to equal 180. They will be supplementary. They'll add up to 180. And so you would just solve that. We would do the same thing with the other pair, 4y minus 1 and 65. Together, those add to 180. We had a quiz over this, and a whole lot of people knew that there was something to do with the opposite angles, but they set them equal. They said 63 equals 3x. Nope, not true. They are supplementary. They add up to 180. So let's go ahead and solve both of these now. We've already done the new part of setting it up, and now we just solve these. So here, 180 minus 63 is 117. And then 117 divided by 3 is 39. Over here, I'm going to just put together the -1 and the 65. And then, let's see here, subtract 64. And 116 divided by 4 is 29. So there are your answers, 39 and 29. Alright, next up, number 20. Number 20 comes out of lesson 10.5, and 10.5 had to do with angles related to a circle. And this kind of looks familiar to what we were doing before. We have an angle here, we have some arc measures here, and so you might think one of two things. Let me just go through what not to do first. Some people might say, oh, this is the center right here, and so therefore the central angle will be the same. It will also be 140 degrees. That's my answer. Well, that's not right. Do you know why that's not right? Because we don't know for sure that this is the center. It kind of looks like it, but actually if you look closely, I don't think it is. I think the center looks more like right here. Even so, you don't see a dot there, and there's nothing that tells you that's the center, so you can't assume that it is. Some people might say, oh, don't we have a rule, like something, if you have an arc and you have an angle, that angle is half, and so this would be 70 degrees? That's not right either. That rule relates to if you have an inscribed angle, an angle that is on the circle itself, not somewhere in the middle of the circle. So, what do we do here? Well, this is where we start getting to the theorems that are not quite as straightforward, and again, you don't have to memorize them, but you do have to know how to work them. And the theorem says, take the angle on the inside, in this case x, and that is going to equal 1/2 the two arc measures that angle forms. Notice that this angle forms 140, and this angle right here, which is just vertical to that x, this would also be x degrees, forms this arc measure of 146. And so basically you're going to average them. You're going to add together the two arc measures and times it by 1/2, or you know that timesing by 1/2 is the same as dividing it by 2. So I would actually add those together. 140 plus 146 is 286, and then either times by 1/2 or divide in 2, same thing, and you get 143. So The answer is 143. Also, notice 143 is exactly halfway between 140 and 146. It's the average. All right, this page of the review packet is mainly lesson 10.5 and 10.6. We did lesson 10.5 on Thursday, March 26th. So 10.5 we did on Thursday, March 26th. And lesson 10.6 we did on Friday, March 27th. The reason why I mention that is because if some of this seems unfamiliar to you, you may have been gone. I had a lot of students gone. Those were the 2 days right before spring break. So if you haven't taken down the notes from those days, you should definitely do that. And I'm also glad to help you, but you're watching this video and that's good, so this will also help you. Okay, so in 10.5, which was all about angles, we have another theorem that describes this situation. If you have a secant and a tangent, or if these are both secants, or if they're both tangents, what happens is you have this outside angle formed, 34, and that's going to be equal to 1/2, and then you're going to take these two arc measures, in this case 198 and x, and you're going to subtract them. And you have to subtract them in order, the outside one minus the inside one. So 198 minus x. So you're not really averaging them because you're subtracting them. That's the main difference with this set. From here, you have a couple options. You could actually distribute the 1/2 in if you want, or what we did sometimes is instead of multiplying by 1/2, we actually multiplied both sides by 2. That way that 1/2 goes away, and we just have 198 minus x. On the other side, though, we actually do have to multiply by 2, and so that'll be 68. From there, I'll go ahead and solve it, minus 198. And what we just did there, that's not something new that we learned. The new part was just setting it up. The solving, the timesing by 2 or distributing, that's up to you. That's just algebra. And it might not be the easiest part of algebra, but it is something that you need to know how to do. Again, if that's something I can help you with, let me know. Okay, 68 minus 198 is negative 130. And over on the right side, we just have negative x. And to get x totally by itself, let's divide by negative 1. And so x equals positive 130. All right, number 22. This should look somewhat familiar. This looks like number 20 that we did on the previous page. But it looks a little mismatched. Here's what I mean by that. In order to use the theorem that we did on number 20, everything has to line up. The 25 degrees, the x, has to line up with either this angle here or this angle here, and we don't know those angles right now. But remember, if you have an x pattern, like we do, and if this is 137 degrees, we should be able to figure out what either of these angles are. And there's a couple different ways to do it. The way that I would do it is I would realize this is a straight line here and it adds up to 180. So if you do 180 minus 137, you get 43 degrees, and that is going to be the measure of both of these angles. You're only going to really use one of them, but you can use either one because they're both the same. They're vertical from each other. So now we're going to use that same theorem formula that we used before, which says you take the measurement of the angle, and that's going to equal 1/2 the two arc measures added up. That's kind of a way of putting it right there. So if I fill that in, we're going to have 43 degrees, that's what we had to figure out first, equals 1/2. So 1/2 25 plus x. I suppose you could put those in either order because it's addition. Again, it's up to you. If you wanted to distribute the 1/2, you could do that. Or if you wanted to multiply both sides by 2, sometimes I just make a little note, times by 2, times by 2. That will get rid of this 1/2 there. And that's probably what I would do in this case, just so I don't have to deal with any fractions. 2 times 43 is 86, and then just subtract 25 from both sides, and we get our answer of 61 degrees. Okay. Look at how similar numbers 23, which we're on to now, and 21 look. They both deal with the same type of situation. The only difference is that in 21 we had a secant. If you look closely at 21, you can see that is a secant. It does intersect. It's not just a tangent. And in number 21 we also had a tangent. And in number 23 we have two secants. They go right through. Well, you're going to use the same formula for both. So just to review, what we did above for number 21 is we said the measure of the angle equals 1/2 the outside arc minus the inside arc measure. All right? And so we can just fill that in. 29 degrees is our angle, equals 1/2. We don't know what the outside arc is, so that's why it's marked with an X, minus 56. Again, I would use the method of multiplying by 2 to get rid of that 1/2. Just make sure you actually do multiply the other side. And so 29 times 2 is 58, equals X minus 56. Then you actually have to add 56 to both sides to get rid of that. So 56 plus 58 is 114. And I would say that looks about right. I mean, you can't rely on the looks alone, but it looks about right. Notice it's not just what you get when you times 56 by 2. That'd be 112, which is not the same thing. All right, number 24. This one is just like the other few that we have done, number 23 and 21. Even though it's a slightly different situation, we have a tangent and a secant. In 23, we had two secants. In 21, we had a tangent and a secant. So there's a few different situations that we can apply that same formula to. So let's go ahead and do that. 24 equals 1/2. Outside arc is 118 minus inside arc is X. Has to be in that order. Again, I'm going to multiply both sides by 2. 2 times 24 is 48. And on the right side, 118 minus X is all we have. There's no parentheses anymore. Okay, I would subtract 118 from both sides. So 48 minus 118 is negative 70. Do keep track of your signs here, because on the other side we have negative X, and so you might realize what's going to happen. You can divide both sides by -1, or you might just realize the answer is going to be 70. Okay, number 25. Even though this one's slightly different than any of the ones we've had so far, because it's two tangents meeting at an angle outside the circle, same formula as the last couple. We're going to take the angle, this time we don't know what it is, equal to 1/2 the outside arc, 218, minus the inside arc, 142. In this case, there's no reason to multiply by 2. I would just follow order of operations. 218 minus 142 is 76. And then let's take that times 1/2. Or divided by 2 is the same thing. And so X equals 38 degrees. Yeah, I think it looks like it's about 38 degrees. That would make sense. All right, 26 starts the last lesson that we did before spring break, lesson 10.6. Notice we're not talking about angles now. You don't see any degree symbols. We are talking about side lengths. And we learned 3 theorems in lesson 10.6. This represents the first theorem. It says if you have two chords intersecting in a circle, that they will split each other into each two segments, and you can just multiply those segments by each other and set them equal. So I could do 6 times x equals 3 times 4. Now, you have to multiply the ones that are in the same line segment. So I have to do 6 times x. It's up to me whether I want to put 6 times x on the left or the right, but whatever goes on the other side has to be 3 times 4. Okay, so 6x equals 12, and that would make x equals 2. That's just kind of an introduction to this theorem. Do we have any others? Looks like we don't have any others quite like that one. So we had a couple other theorems that we learned as well. The second theorem that we learned in lesson 10.6 was if you have two secants intersecting a circle, meeting at a point outside, you're not going to do exactly the same thing. You're not going to do 4 times x, 5 times 3. You're going to do something slightly different. You're going to do 5 times the whole thing. So how big is the whole thing? 5 times 8, right? The whole thing, you'd have to add together 5 and 3. And the same type of deal happens here. We have 4 times, what's the whole thing? It's not x, it's not 4, it's both of those added together, x plus 4. And you do need to have parentheses, because in the very next step you need to distribute. We're going to have 4x plus 16. On the left side, 5 times 8 is 40, and then you just solve it. Again, setting it up is the new thing that we learned. Solving it is not new. So just subtract 16 and we get 24, divide by 4, and we get 6 as our answer. Okay. The third theorem that we studied in lesson 10.6, that Friday right before spring break, had to do with if you have a secant and a tangent. Notice that this 10 is meeting the circle just at one point, its tangent. And so this is going to be a little bit different of a formula. You're going to take the tangent part first, 10, and you're going to square it, and that's going to equal the same thing we did with this secant that we did with the other secants. You're going to do 5 times the whole length. And the whole length is not just 5, it's not just x, it's both of them added together. I'm going to write it as x plus 5. So we'll have 100 equals 5x plus 25, because you got to distribute. Subtract the 25 from each side, and then divide by 5, and you get 15 as your answer. Okay, this whole last page of the review deals with lesson 10.7. That was the most recent lesson, the lesson that we learned on Monday, April 6th, after spring break. So hopefully this is more recent in your memory. And what we learned is that a circle has an equation. And the equation is going to be written like this, like number 29, where you'll have a x with a number in parentheses plus y with a number in parentheses equals some other number. And what we learned is that the number with the x is going to represent the center of the circle. All circles have a center. It's kind of one of the most important parts of the circle. But what you have to remember is it's given to you with opposites. So the center of this circle is not 3, negative 6. It's actually negative 3, positive 6. Then this last number has to do with the radius, but it's not the radius, not exactly, it's the radius squared. So if you want to know what the radius is, you have to square root that number. So the square root of 49 is 7, so the radius of this circle is 7. And that would give you enough information to graph that circle if you wanted. You could graph the center and then draw segments 7 units away, and you could find the radius. All right, here's another one. So, since this is negative 4 or minus 4, that means the center x value is actually going to be at positive 4. Now notice there's no number with the y. What's actually happening there, and you don't really see it, is it's doing y plus 0 squared, but since y plus 0 is just y, they don't write that, they just write y. So basically if there's no number with the x or the y, that means there's a 0 there. And lastly, the radius, since this number is 9, you have to take the square root of that to get the actual radius, so that is 3. So if you did have to graph this, and you don't have to graph this one, but just to show you, you would make a mark at 4, 0, and then you would count 3 in every direction, and then you could do your best to draw a circle that represents that information. Okay, here's one that's given in reverse, where we are telling you the center and the radius, and you have to put it into the equation. Well, if what we were doing in the last two problems made sense, then this should make sense too. We're going to have a parentheses that has x in a number squared, plus another parentheses that's y in a number squared, equals the radius squared. But what you got to remember is it's opposites. I'm just going to write that in again, opposites. So it's not going to be x plus 2, even though that is positive 2, it's going to be x minus 2. Same thing with the y. I know that's positive 7, but when we put it in the equation, it's going to be minus 7. Now, the radius number goes over here, but it's not just going to be 4. You have to square it. So 4 squared is 16. That's the number. And that's your answer. That would be the equation for this circle. Here's another one right below that. Notice the first number is 0. That means the x is not going to have a number with it. It's just going to be x squared. Plus y and a number squared equals the radius. The y number is negative 8, but remember, opposites, so it's actually going to be plus 8 squared. And the radius is 6. Square that, and that's going to give you the number that you see over here. So you'll get 36 over there. Okay, and the last two problems have you actually graphing one, and on the test you'll have questions like this, but it's also going to actually ask you what is the center and what is the distance of the radius. So get in the habit of actually writing that out. Again, if you're looking at these numbers but look at them with opposites, the center would actually be negative 3, positive 2. Go ahead and graph that. Negative 3, positive 2 is right here. Now this number represents the radius, but it's not just the radius. This is the radius squared. So you have to take the square root of that to come up with the actual radius, which is 2. Now what I would do, once you have the center graphed, is I would count to the right, left, up, and down of that 2 units and make a marking. Those points will be on your circle. If you know how to draw a circle, great. But I know some people have trouble with that. And so here's my hint. Once you have those points drawn in, just draw a slight curve. This is going to be even harder for me because I'm writing on a tablet here. But draw a slight curve and then go ahead and draw the full circle. It'll help you to make a circle better. Now I'm not going to be grading your art talent here. But it should look like you were trying to draw a circle. It shouldn't look like an oval or a square or a rectangle. That's also why I'm having you put this information here, to make sure that you know how to do this, even if your hand doesn't draw what your mind is thinking. Alright, last one. The center, remember opposites, the center is actually going to be at positive 1, negative 3. So positive 1, negative 3 is right here, and the radius squared is 25. So if you want the radius, you have to square root that, and you get 5. So count in 5 by 5 in all directions, and you're going to have a curve or a point there, 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 and off the graph, you'll just have to estimate about there. And then make sure you do draw the whole circle. Again, you should be able to draw it at least as well as I did, which is not very well. You should probably draw it better than that. But if it doesn't look like a circle, I mean, if it looks like something different than a circle, then yeah, you could lose points for that. So try to draw the best circle that you can. All right, good luck with studying for the test.